In this chapter, we will be looking at rational expressions. In this lesson, we will be adding and subtracting rational expressions.
Okay, so we're going to take a look at what it means to add and subtract rational expressions. And the truth is, this is exactly the same as adding and subtracting regular fractions. And so I tell you what, I'm going to kind of sidestep this. I'm just going to talk about this using just a regular old example from way back when. Let's say that you were having to add, I don't know, let's say 2/3 plus 4/5. Okay, so here, let's maybe zoom in a little bit on this. So what are you going to do? Well, first of all, we want to get common denominators. Okay, now with number values, you might have thought about factoring them in order to get the smallest common denominator. Okay, when it comes to rationals, you absolutely have to factor in order to get that to work out reasonably well. If you just always multiply the denominators together, like I know some people do, you're frequently going to miss over a much simpler way of answering the problem here. But in this case right here, if I want to get a common denominator, what you got to do here, the reason why you need a common denominator is you have to think about the denominator being the size of the object that you're adding. Like this right here, don't think of this as 2 divided by 3 so much as 2/3. Okay, this is 2/3. Over here I've got 4/5. Okay, so I'm adding together 2 of something and 4 of something, but those somethings are very different. But with fractions, I have the ability to make that denominator, the size of that object, the same. And I can do that as long as I multiply the numerator and denominator by the same thing. So if I multiply this by 5 and by 5, multiply this by 3 and by 3, 2/3 is really the same as 10/15. 4/5 is really the same as 12/15. Okay, so now I've got 10/15 and 12/15. Altogether, that's 22/15. Okay? Does that make sense? I hope so. Anyway, that's just that's essentially what we're going to do here, except when we start dealing with rationals, you're going to have to identify the non-permissible values as well. And you might require a little bit of factoring in order to get the smallest common denominator, so that you're multiplying both fractions here, the numerator and denominator, by the smallest value that you can. Anyway, let's take a look at some examples. All right, so notice in this case here we've got 2/x and 4/x. I don't even know how to say that properly, but I'm guessing. So the denominators here are exactly the same. Okay, so we might write at this point here that this is only going to work as long as x doesn't equal 0. And because the denominators are the same, we can simply add the numerators together. I've got 2x here and 4x here. So that's 6 of them total. Again, with the stipulation that x can't be equal to 0. Take a look at the next one here. This is more like the example that I did just above here. So I've got 5d halves and 3c sevenths. Okay, well, again, the size of those objects, they're very different. 2 and 7 are prime numbers, which means that what I got to do is I'm going to multiply them together. So I have to multiply numerator and denominator here by 7, numerator and denominator here by 2, just so that we're dealing with the same size of object here. Now, that means up here, this is going to end up being 35d 14ths plus, and this is going to be 6c 14ths. So how many 14ths do we have total? Well, 35d plus 6c. I can't add those together, okay, because they're not like terms. But they would all be over 14, okay? If I could add those together, I would have that many 14ths. There's no non-permissibles here because there's no variable in the denominator. Okay? The denominators are 2 and 7 respectively, and that's not a problem. That's not a problem at all. It's only if there's a variable down there that could be a 0 that becomes a problem. All right. Okay, this is a bit cruel, this one right here, because order doesn't matter with addition. So a plus b, b plus a, these are exactly the same. Okay, so I'm going to make this second one here look prettier by simply writing it in standard form, in alphabetical form, order, I should say. Okay, now this is 11 a plus bths. This is negative 7 a plus bths. So all I got to do is put the numerators together. Okay, and 11 minus 7 is 4. Now here there will be a non-permissible, and the non-permissible is that a plus b can't be allowed to go to 0. Now with two variables here, whoops, I don't know why I did that twice. It's weird. With two variables here, I'm simply going to say that a can't equal negative b. And so that's going to follow all the way down. A can't equal negative b, a can't equal negative b, and so on. Okay, whoops. Not giving myself much room there. But anyway, there you go. Okay, now once again our denominator is starting to get a little bit more involved here. But notice it's the same. This is 3x, x plus fourths minus 2x plus 5, x plus fourths. The size of the object that I'm adding is the same in both cases because the denominators are the same. Notice that if the denominator is x plus 4, that means x cannot be allowed to equal negative 4. But now all I have to do is add the numerators together. There will be mistakes made on this one unless people are careful. Oh, guaranteed, guaranteed. I'm going to write this out in kind of very, very slowly. I'm going to do this very, very slowly. So when I write these together, it's going to be minus. Now, if I write it like this, I've written it wrong. But I suspect a lot of people, this is immediately how they would write that. Okay? See, but in this case here, I'm subtracting 2x plus 5 of the x plus fourths. I'm subtracting the whole 2x plus 5. If you just throw the negative in front like this, you're only subtracting the 2x. So you need to put parentheses here, and then you need to distribute that negative through. So this becomes 3x minus 2x minus 5 all over x plus 4. And then the whole time around here, x can't equal negative 4, x can't equal negative 4. And now 3x minus 2x is going to be x. Let that minus 5 there. It stays, and then we got over x plus 4, and x can't equal negative 4. Okay, so there you go. Just be careful with how you deal with those negatives there. Over here, got x over 2 minus x, minus 2 over x minus 2. Okay, now these are written in a different order, but this time there's subtraction in between. So this is a little different. Okay, so what I'm going to do is this one looks good. X minus 2 looks totally fine. This one doesn't look good to me. So I'm going to pretend, instead of being 2 minus x, I'm going to think of this as 2 plus negative x. Because when it's written in as an addition, then I can change the order. I don't like the way that looks, so I'm going to make this x over negative x plus 2 minus 2 over x minus 2. I'm not even going to deal with the non-permissible until I get this thing looking pretty. And now look at this. Look, this is positive x minus 2. This is negative x plus 2. Well, they're not the same. Okay, they're really close, but they're not the same. There's an additional negative here. And then there's this a positive here. But if I factor that negative out, oops, got to factor it out of everything. If you factor that negative out, just by dividing out a negative 1, I can change all of the signs. Okay? And finally, I can move, because I have freedom here. Okay, remember how this works. If you've got like negative a over b, that's the same as negative a over b, which is the same as a over negative b. It's just that you would seldom write it like this with a negative in the bottom. So I'm going to move that negative up to the top here, make that negative x over x minus 2 over x minus 2. Okay, now I can do something with that. The denominators are the same. Everything looks right. Now I'll state the non-permissible. X can't equal positive 2. I'll just put these two guys together here. This is going to be negative x minus 2. So negative x over 2. Sorry, not negative x over 2. Negative x minus 2 over x over 2, where x can't equal positive 2. Now, you may be tempted to start to cancel things here. Okay, because you're seeing some stuff that's the same in the numerator and denominator, but that's not the rule. Okay, that has never been the rule. Okay, just because you see two things that are the similar top and bottom doesn't mean you can cancel them. Remember that there are brackets implied around this. Before you can do the kind of division, okay, think of an order of operations, before you can do the kind of division that you would need to do to cancel stuff out here, you would need to be able to combine these together. You'd have to do the operations that are in brackets. So I'd have to do negative x minus 2 and then x minus 2 down here in order to add those together. Before I could do the division that would cancel stuff out. So because I can't do the addition, because these are not like terms, I'm done. That's a dead end. Okay, you can only cancel things if they're the same factors in the numerator denominator, meaning that they're multiplied. If this was negative 2 multiplied by x, then I could cancel the negative 2's. But they're not. It's negative x minus 2, x minus 2. Addition and subtraction kind of kill that ability to cancel there. So just be careful with that. All right. Okay, now here we truly get a question here where that's going to require a little bit more effort here because the denominators are different. But they are factored. Okay, there's nothing more you can do here. That is about as simple as they're going to get. But let's really quickly just state now. Now I've got two non-permissibles, negative 3, positive 6. Okay, just coming from both of those denominators. And now I'll rewrite this because it'll be easier to see. Whoops. I'm sorry, I'm getting a little bit ahead of myself. I am going to put an x, a 6 down there, but I meant x plus 3. I'm going to have to multiply numerator denominator here by x minus 6. And over here, I will multiply numerator and denominator by x plus 3. Okay? Because that's the only way I'm going to get the denominators the same, is to just multiply by each other. Now, I'm going to leave the denominator in factored form. I'm not going to expand that out because I'm kind of hoping that something up here, when I simplify whatever's up here, is going to have maybe a factor like this that I can cancel out here. Now remember, got to keep saying, can't be negative 3, can't be 6. Over here, same thing, can't be negative 3, can't be 6. And now we'll just multiply this out. This is going to become 3x times x, 3x times negative 6. So 3x squared minus 18x. Now, I'm going to put that in brackets, minus, because I'll deal with the subtraction last here. I'm going to multiply this out here first. That'll be 4x times x, 4x times 3. So that'll be 4x squared plus 12x. Okay, all in brackets. Okay, because there's that negative sign in between, because I'm going to subtract this whole thing, not just the first part. I'm going to subtract the whole thing. And so now I'll distribute the negative through. This will become 3x squared minus 18x minus 4x squared, whoops, minus 12x all over x plus 3, x minus 6. Okay, we're again, x can't equal negative 3 or 6. All right, now we can do some simplifying here. 3x squared minus 4x, so it's going to be negative x squared. Negative 18x minus 12x, get minus 30x times x plus 3 times x minus 6. X can't equal negative 3 and 6. What can I do here? Well, I can take out, see, here's the thing. I can take out a negative x, but it's going to leave me with x plus 30. Because I can't cancel anything there, there's nothing similar numerator denominator, there's really no point. I mean, all I'd be doing is taking out a common x. That doesn't make it simple. That just makes it look different. That's about as far as I can go. That's a good place to stop. Let's come over and take a look at this next one. Okay, now the problem that I have with this one is the way this one looks. That looks odd. It should have the x's up front. So this is similar to the one that it's actually just above it. So what I'm going to do here is I'm going to change the way this looks. I'm not going to even worry about non-permissibles until I've made the question prettier. So I can't really change the order when it's subtraction, but I can if it's addition. So I'm going to treat this as plus negative x. So this will become x over x minus 1 minus 2, 3x minus 2, and I can change the order now, negative x plus 1. Okay. almost the same, except the signs are all different. And so, but I've already seen how I can deal with this. Okay, I can, in that denominator there, take out a common -1. Now, that's not always the most obvious thing to do, but if you're looking at two binomials here, or trinomials for that matter, polynomials, if all of the signs are different, all of them, then I can factor out a negative like I've just done here. Now, just like before, I can move that negative up, and notice that there's a subtraction here. Well, that's going to change. So it'll be x over x minus 1 plus 2 times 3x minus 2 over x minus 1. Now the denominators are the same. Now I can just add the numerators together. But I'll state right now that x can't be equal to +1, because now I'm going to start to work on the combining here. So this will all be over x minus 1. And I'll have x plus, now I'll just distribute that 2 through. I don't have to worry about keeping this all together with when there's a plus sign in the front. Okay, because the plus sign will automatically distribute through. When you do that kind of math here, you'll do that naturally correctly. If this was a subtraction, we don't always do that correctly just without thinking about it. But with addition, yeah, you will. So 2x times 3x will be 6x. 2x times -2 will be -4. Again, as long as x doesn't equal 1. And so we're going to get 7x minus 4 over x minus 1, as long as x doesn't equal 1. Okay. Just a few more. Okay. Now here we go. Starts to get us, force us to do a little bit of work here. So the denominators are very different, except that I can factor this, and I should do that first. So this will be 6x over, take out the common x minus 1, plus 7 over x minus 1. Okay, well now there's a lot more that's similar here. I'm going to stop right now because I'm in the process of adding and subtracting. I'm going to state that my non-permissibles will be x can't be 0 from this one, and x can't be +1. Now, I'm going to add them together. I want to find the common denominator, but I notice with this term up here, there's an x in the numerator, x in the denominator. Well, x divided by x will be 1. Now, not always. If x is 0, that doesn't work, but I've already stated the non-permissible that x can't be 0. So I'm free to do that, okay? Because there's already a restriction on this problem that x can't go to 0, and I got to keep writing that. So that actually frees me up to be able to do this. So now my denominators are the same. All I got to do is add the numerators. So I'm going to get 13 x minus 1 as long as x is not allowed to equal 0 or 1. There you go. You got to like it when stuff like that happens, when you can simplify down to get a common denominator instead of having to multiply up to get it. Okay, now let's take a look at this one. All right, this one's going to be a little bit more involved, because here that will factor down as a difference of squares. So that'll be x minus 3, x plus 3. And then over here, I'm going to have a common 3. Or sorry, wow, not a common 3, a common x. Sorry, I was just thinking about where this one was going to go. X plus 3. And now I can state the non-permissibles because I can see them clearly. From here, x can't equal 3, can't be -3, and from this one over here, can't be 0. Okay, now, unlike the last question, I can't just simplify it down to get a common denominator. Here I'm going to have to build it up here. So the denominator that's missing here, the factor that's missing in this first one is this isolated x here. So I'm going to have to multiply numerator and denominator by x. Here it's a slightly bigger problem. I've got I need that extra x minus 3 in order to make the denominators the same. Remember, the denominators have to be the same because they represent the size of the objects that you're adding. So I'm getting 4x squareds of this, and then 3 times x minus 3 of the same thing. Now that I've multiplied those out here, they're the same thing here. So here's my denominator, and I'm going to move the x up front because it looks better. And I'm going to leave it in factored form. Not going to expand that out. I'm going to leave it in factored form because when I simplify the numerator, I'm going to look for an opportunity to simplify this a little bit here. And if I expand that out, I won't see it. Okay, so right here, we're going to have 4x squared. Again, I'm happy with an addition between these two fractions because my work will naturally take into account the addition translating through or distributing through. But if it was a negative there, I have to be more careful. But I'm going to get 3x and then minus 9. Okay? Where x, again, can't equal 3, negative 3, or x. All right, now we're going to take a quick look at this right here because, I mean, that's just a nice trinomial. Will that factor into an x minus 3 or an x plus 3? Let's just think about this for a second. So I'm just trying to simplify this. We're going to give a couple moments time to this. Like, can I take an x plus 3 out of that? If I do, let's just see what happens here. If I try to factor this by taking out an x plus 3, then let's say that in order to get the this to be the same as what's up here, I'd have to put a 4 here. And now 4 times 3 is going to be 12. In order for the final product here to be 9, this has to be negative 3. Now, 4 times 3 is 12, minus 3 would get you positive 9, not 3. Okay, so that doesn't work. Okay, I can get the 4x squared, and I can get the negative 9 that I need here, but I can't get that middle term to pop out, so that's not it. Okay, it should be clear that x is not a factor of everything here, because it's not a factor of the negative 9, so I'm not even going to test that. Let's try this x minus 3. Well, again, this will have to be 4x in order for the first product here to be 4x squared. If this is negative 3, this has to be positive 3 here. Now let's just take a look here. Do I get that middle term 3? So this will become negative 12. This will become positive 3. Negative 12 positive 3 is negative 9. I still can't get that 3x there. So even if that does factor, it's not going to allow me to cancel anything. That's about as good as that's going to get. Good, there we go. Next. Oh, here's a very similar problem to what we just did. Okay, so first thing we're going to do here is factor, and we got a difference of squares here, so it'll be x minus 2, x plus 2, plus 3x over, okay, we got a common x there, x plus 2. Now I can state the non-permissibles, because I can see them all quite clearly. X can't equal positive 2, x can't equal negative 2, and then right here, x can't equal 0. And again, that's going to carry all the way through. Now, before I go on though, I notice right here I've got an x over an x. I can cancel those out. Now remember, x divided by x would be 1, so long as x isn't 0. That's 0 is the only number that doesn't work here. But it's okay because that's one of my non-permissibles. X never does equal 0, so I can feel free to divide that out. And so now this is going to get me x over x minus 2, x plus 2, plus 3 over x plus 2. And then I got to include my non-permissibles. But now when I look at my, my denominators here, notice that really what's missing here is just an additional x minus 2 here. So x minus 2, putting that in the numerator denominator so that my denominator here will be x minus 2x plus 2. Then I'll get x plus, I will distribute that through, get 3x minus 6. And again, at this point, I'm thankful for that addition in between so I don't have to worry about distributing a negative. Putting that all together, now I would have normally liked to move down with this equals, but I'm running out of room here. So this will be 4x minus 6 over x, whoops, just put this in the right order. I'm not going to change the order here. X minus 2, x plus 2. Now, let's just think about this first because I'm almost done. There is a common 2 between these two, but if I factor out a common 2, I'd be left with 2x minus 3. Now, nothing can get canceled here, so that's about good. There's really no reason to go beyond that because I won't be able to gain anything by that. So there's my final answer. And then one more question. This one looks like we're ending on a slightly easier one here. I try factoring. There's no factoring to be done because these are all about as simple as they're going to get. So we're going to multiply those denominators together, meaning that I'm going to put x plus 3 in the numerator and denominator here, and I'll put a 5 in the numerator and denominator here. And then I'll state that x can't equal negative 3, okay, because that's my restriction from there. There's no restriction from that first term because 5 is in the denominator, it's the only value there, and that's totally fine. Okay, so by denominator now will just be 5 times x plus 3. Again, I'm not going to expand that out, but here I will expand this out. It'll be x squared plus 3x. Happy about the addition there, that makes this plus 15, where x cannot equal negative 3. Okay, now once again, I'm looking at this and I'm trying to think, okay, could I factor that? Is that even possible? Okay, but it would only be useful to me to factor if there was this x plus 3 in there. So let's just take a look at what the other factor would have to be. Well, in order to get x squared up front, this would have to be x. So that when I do x times x, I get x squared. Okay, good. To get the 15 at the end, well, I've got a 3 in here already, so when these two are multiplied together, I get 15. So this has to be 5. But now let's see, can I get that middle term of 3x to pop out here? So x times 3 is 3x, but 5 times x is 5x, and when you add those together, you're getting 8, not 3. So that doesn't work. And since x plus 3 was the only factor down there that could possibly have canceled, this won't factor into anything useful. That's as far as we're going to take it.